Hello, everybody. Welcome to our talk on doubling your performance of fraud detection system using graph database and machine learning and AI. I'm Abhi. I'm Director of Sales Engineering at TigerGraph, and I would ask you to join us for roundtable tomorrow, and it's going to be on real-time fraud detection. Is it real? And my background in graph databases, machine learning, have few patents in this area here and there. With that, I will actually move into something which really matters. And that is our introduction to TigerGraph first. And let's look at this. TigerGraph in 2012, founded as a company for a distributed graph database, came out of stealth in 2017 with the solving biggest challenge of connecting the various different diverse data sets for traversal. And we have some very big customers using it for customer 360, entity resolution use cases. And the next one, the biggest value is advanced analytics, what we provide on the data set. Your ability to go multi-hop inside your data set without using some extra hardware is the biggest value, which shows up in the supply chain use cases, fraud detection use cases, whether it's a device fraud, financial fraud, or application level frauds. The third value of TigerGraph is in machine learning database. When you store your data in a graph format, and the biggest value you get is that you can run graph-specific machine learning algorithm, which you can't do it on your regular two-dimensional data structure like page ranking, similarity detection, and Louvain. With introduction to graph on the side and introduction to TigerGraph on the side, let's move on to the real problem in hand. I pulled up this 2018 record data set, which talks about $30 billion losses on the fraud transactions worldwide. But the biggest challenge here was that 1 out of the 5 blocks were only fraudulent. 4 of the 5 were actually false positive. And you can see what kind of impact that would have when you see $118 billion were actually blocked sales only in the United States for that. 40% of the users who were actually flagged as false positive were trying to pay more than $250. So your margins are impacted. And on the demographic side, people earning more than $75,000, less than 35 years of age, are at high risk of being flagged as false positive. So customer experience, right? The lifetime value of a customer, his experience on your platform, that is all impacted by these kind of activities. And this is where Graph reduces your false positive, increase your rate of fraud detection. And the biggest reason behind that is the semantics of your use case. So let's look at a use case, which is, I'll just map it out on the screen. And what's happening over here is that this is very common to all of us, right? You got a customer. We are customers having an account, having a credit card, making a payment. When I made a payment, I used the device. And if I use that device, now bank knows that this device has been used with my account. And logically speaking, payment, it takes 2 to do a payment. So there is another account on the right-hand side, which also has a customer associated with it, and that has all his own details. Now, this is your logical view of the data, very, very easy to explain. You know, if we need to find out that why customer 1 and 101 are interlinked, all we need to do is find some path in between. This is easier said than done because our data is not really stored like this. It's more like a RDBMS structure. So exposing these hidden patterns, whether on a device level, whether there is a mule network in between, or whether A is transferring money to B to C to D and D back to A, it becomes extremely difficult to find that out because RDBMS structures run into that looping problem where, self-join problems where you will lose performance and it becomes cost prohibitive to run such an expensive system to find randoms and ad hoc queries on your data sets. That problem is solved by Graph because we store the data exactly what you're seeing on the screen. It's not the visual part of it. It's how the technology behind the scene stores the data just 1 hop away from its neighbors. Everything is interlinked together. So right now, rather than going into the tables, you're just getting to your data point and finding which direction it goes to or which direction you want to head to find a correlation. So this is basically a shortest path finding mission inside the world of interlinked data sets. So Graph solved this problem of finding correlation, deep link, multi-hop analytics, and that's why it has become the core path of the top 7 banks in the world using TigerGraph to do, making it as core of their graph strategy. Example being a credit card fraud, right? I mean, if I'm using a device or a merchant whose PDA has been historically associated with a fraudulent transaction, and I have never transacted there before, the bank would like to flag it, give it a low confidence. Merchant analytics. I go to Macy's, I go to Nordstrom, I go to Panera. A lot of people in my community does the same. Can you conclude, looking at this buying pattern, that these people are probably in the same mall? These merchants are in the same mall. High-level merchant analytics. Similarly, clusters of behavioral patterns. Similarly, credit card scoring on the real time, trade surveillance. I'm not supposed to transact on securities without getting approval from my institution because I work for a financial company, but somebody is doing it using their wife's account. How do these things get interlinked together? And wealth management group. There are various different cases which require, well, there are a lot of cases which require this kind of joining of the data set together, interlinking of them to get the highest value out for the customer, to get some BI on top of it, to get some feature extracted for machine learning algorithms on top of it, finding fraudulent transaction. So that is why graph's nature, the very nature of interconnectedness comes into rescue. And specifically for TigerGraph, why we are being utilized, because we are the world's first native parallel graph. Historically, companies had challenges with dealing with more than 200, 300 gigabytes of data. Now you don't. You can scale us out to terabytes of system and still get a real-time performance. You don't have to have T+1, T+2 system. On the fly, transaction is getting you deep link analytics, which can make your machine learning algorithms smarter. Similarly, the cost of ownership on TigerGraph is much more lower because we are distributed, so you don't need expensive machines to run it. And there are various different capabilities, as you can see on the screen, which are going to be very useful. If you have any specific questions, feel free to ask me in the Q&A section, and I'll be glad to answer those. Let's look at a couple of the top use cases from the global banks. This is a typical example of list-based fraud, Frankenstein fraud. If I know the devices that has been historically used for fraud detection, and as I was saying earlier, I use a merchant whose device was used for fraud, bank would like to know, right? So this is the interconnectedness of devices, IP addresses, cookies on people's machine, their past record, their correlation, their household relationships, all being joined together to find the confidence for the feature extraction or a machine learning algorithm to give you a confidence score, to give your machine learning algorithm a confidence score of that there is a possibility this loan application could be fraudulent. The next use case, which is emerging and becoming very popular in the industry, is using the advanced graph algorithms to do what you can't do on your regular machine learning two-dimensional structures. And that includes things like interconnecting the merchants and the policyholders or your credit card holders based on their buying pattern. If I buy at one store and I also buy at second store, and a lot of people in my community are buying at these two stores, can we link the stores together based on just the density of people who are shopping there? And if they are linked together, now in a community, whatever is the parameter of community, geolocation, or it could be, diaper selling shops, can we correlate and say that, oh, okay, they are linked together, but these vendors are more important to me than other vendors. And reason being, just like PageRank algorithms, bring the top search results for Google for you on the top. Similarly, this rank algorithm can bring the top merchants for you on the top. And merchant being divided into tiny communities, now you can rank those communities based on the average page rank, and some of those communities hold your fraudster data, right? I mean, it's an unsupervised machine learning algorithm. And now you know what community to focus on, which has been damaged by these fraud attacks. Or if there are too many fraudsters in that community, now you can zero in that this is probably your ring lies, the fraud ring lies. So there are very intelligent ways of using graph algorithms to do what you would like to do for your next generation fraud detection system. And graph is right there, backed by TigerGraph. To look at it from a different perspective, how would you implement such a system? You've got core technology group. machine learning, data scientists, you got modeling groups with statisticians and playbook and rulebook holders, and you got the analysts on the top who are actually eyeballing these fraud systems and saying, oh, this is a false positive or this isn't, depending on what kind of fraud you operate in, fraud area you're trying to address. So with that in mind, what I wanted to tell is that TigerGraph basically fits in and provide value to all of these groups. So we form the backbone of your overall fraud detection strategy. That also means machine learning, as I was saying, finding smarter feature set. Is there a circle in this transaction? If this device has been used by more than 10 fraudsters in the past. So all those kind of variables can be fetched and fed into your machine learning algorithm to get much more smarter results. On the other side, we also have very smart toolkits which go on top of the graph database, right? So it's just not the database. You get a toolkit which will have dashboarding capabilities, which will have investigative capabilities, which would have, raising the flag or SAR generation or alerting system in place. So all the pillars, as I was showing you earlier, from definition of a graph database to implementation of business specific rules to the visualization like this, what you're seeing on the screen, we bring all of them together and provide you with a complete end-to-end solution. I would like to wrap this up by pointing you to our TigerGraph Cloud. You can reach out to TG Cloud. There you will find a lot of different toolkits. Fraud detection toolkit is also there. Maybe members from your technical team can go in there, start our fraud detection tool, and just run it and see how complicated queries are possible on TigerGraph. They come with the data set for you, to try it out. I mean, this has details about user transactions, user using different kind of devices. There are already queries which are written inside TigerGraph in our TG Cloud Starter Kit instance. And the best thing about this is that we also have a free tier, so nobody has to go in and pay for it. You can use our free tier to see what are the capabilities around TigerGraph over there. With that, I will open this session for Q&As and looking forward to answering your questions. Thank you.
Perfect.